All right, hello everybody. Lab 3, um, data modeling. So as I said in the announcement, this is my favorite topic. I am delete that one. And now you see the system user table by itself down here. And the self-referencing relationships, which means that when we add a system user, we want to know the system user that added that row. And so when we add a system user, we make an entry into the created by column to indicate which system user inserted that row. Or when we update a row in the system user table, we enter a system user ID in the last updated by column of the system user table. Okay, we'll see more about self-referencing relationships here in I think it's lab 5, and you'll understand more about how that works. All right, so now that we've gotten rid of all those relationships, I'm going to scroll up here and we see that we have a much cleaner data model, and I'm going to maybe just consolidate a little bit, trying to keep lines from crossing too much. Move things so that it looks a little cleaner here. Move the common lookup. Up here, and this is the one we're going to talk about next, the common lookup table. Okay, we've got a fairly clean looking diagram here. Okay, the common lookup table, what is that? The common lookup table does support the business, but it's not a business object itself. And you can think of the common lookup table as a validation table or a control table. It controls the valid values that can be put into our business tables. Okay? For example, we take Visa, MasterCard, and Discover Card in our business. Those are the only 3 credit cards that we take. Okay, so we put those in our common lookup table here, and then in our membership table, you'll see that there is a credit card type here. And so when somebody comes in and opens a credit card, and if they hand us an American Express card and we try to put American Express into the membership, it's not allowed, because the only values that can go in here are values contained in the common lookup table, which point to Visa, MasterCard, and Discover Card. Okay, so that's how the common lookup table works. That's the purpose of the common lookup table. Okay, now I'm going to scroll to the top here, and we are going to talk about each of these tables and the relationships here. I guess one more thing before we talk about that, I'm going to go back to, you see the notation here. You see this is called the crow's feet notation, okay, because you see here a crow's foot attached to that box there. And what does that tell us? I'm going to go back to my browser for a minute to show you that notation and what it's telling us. It's telling us the cardinality, okay, as far as relationships go. So here's a website that helps us understand that. So student to seat, that's a one-to-one relationship, right? Every student occupies one seat, and one seat is only occupied by one student, okay? One-to-one relationship between students and seats. Instructors and courses, that's a one-to-many relationship. And so our crow's foot here represents that many relationship. An instructor can teach many courses, okay? And any one course is only taught by one instructor, okay? So one instructor, many courses, one course, one instructor, okay? And that's what's represented on with the relationship notation here, okay? Students to courses. Let me just get all of those so that you can compare them as I go. Okay, students to courses. Students can take many courses, and each course has many students in it. All right, so that's a many-to-many relationship, and so we see the crow's feet on both sides. And then professors to sections. We see that a professor can have many sections, but and you see the O here, and that can stand for zero or optional, okay? So the professor might not have any sections. So the professor can have zero or one or many, zero or many. So it's an optional relationship there with professor to section. Now, going the opposite direction from section to professor, every section must have one and only one professor, okay? So we have the double bar here saying that it's a mandatory relationship that a section must have one and only one professor, whereas a professor can have zero or many sections. All right. Okay, we're going back to our diagram now, and I'll maximize my SQL Workbench again. All right. Let's look at items, rental item, and rentals. Let's start with rentals. A rental is a transaction. Someone comes into the store and rents, okay? That's a rental transaction. And when they come in to rent, what do they rent? They rent items, okay? The items like DVDs, Blu-rays, Xbox, those kind of things, right? So when they come in and do a rental, we insert a row into the rental table which has a rental ID, okay? And we'll want to know the customer who did that rental, the checkout date, the return date. All right, now, when they do a rental and they rent items, an important part of the relational model that I've mentioned previously is that we can't have lists inside of a table, right? A table has rows and columns, and any cell within the table, any field within the table, has one value. We call that an atomic value because if there's one value, it can't be a list. But when someone does a rental, they can rent 2, 3, 4, however many DVDs and Blu-rays they want in the rental. So how do we show that in our database? Well, we have a separate table for the rental items, okay? So when they come to check out, we insert one row into the rental table, and then we insert into the rental item table one row for every item that they are renting. Okay? And so for that row going into the rental item table, there is an ID to identify that row. And then the next column is the rental ID. So you see that that rental ID is the rental ID of the rental table, okay? And that establishes the relationship between the rental table and the rental item table. So we call this a parent-child relationship, where rental is the parent table and rental item is the child table. The one parent can have many children. And when I hover on this line, you see that the rental item in the rental ID table on the left references the rental table, the rental ID column in the rental table, and you see those highlighted, and that that depicts the relationship. Okay. Now, in our implementation, we deal with keys. Okay, so rental ID is the primary key of the rental item table, and so rental ID on the left in the, let me make sure I said that right. So the rental ID is the primary key of the rental table, and in the rental item table, the rental ID then is a foreign key. And don't let that term throw you, okay? Foreign key, that just means it's a link. It links us back to the parent table. Foreign key is a link key. And the foreign key is always the primary key of the parent table. Okay, important concepts here. So replay this if you need to have that sink in, okay? The rental ID on the left is a foreign key pointing us to and linking us to the rental ID in the parent rental table. Now, Oracle will enforce that relationship, and MySQL, being a relational database, does also, but we will be doing all of our work in Oracle. So in our create table, and you saw this in lab 2, we had constraints. We had foreign key constraints, and that tells Oracle the relationship between the two tables and tells Oracle to enforce that relationship. So what do I mean by that? When we go and insert a row into the rental item table, Oracle will not let us insert that row unless we provide a rental ID. Every rental item must be tied to a rental. And so Oracle will not let us insert that row without a rental ID that links back to the rental that that item is part of. Okay, so we see that in our model depicted by the crow's foot with the solid bar. It's a mandatory relationship. And actually, I was talking about the one on the right here, rental item to the rental table. There must be, for every rental item, there must be a rental that it is linked to. Now, you see that this is a mandatory relationship going the other way also. For every rental, there must be one or more rental items. That's a mandatory relationship. There can't be a rental without a rental item. You wouldn't, business rule, right, in our business, you don't do a rental unless you're renting an item. Okay, so therefore, when we insert into our rental table, we need to also insert into our rental item table to ensure that every rental has rental items, and that we call that a referential constraint. And you will see those kind of constraints later in your database career, okay? On how the database enforces those. Now let's go to items. So the item table here, so rental, let's do it from the rental item table. So we see in our rental item table that we have a column here, the item ID. Okay, so every time somebody rents a DVD, so let's say we have a Blu-ray, Harry Potter 1, okay? And that can be rented multiple times, right? So somebody comes in and rents Harry Potter 1, and then they return it, and then somebody else can rent the same Blu-ray. We don't want to put all of the information about that item into the rental item table every time. We don't want to put the barcode, the title, the rating, the release date. We don't want to put that every time into the rental item table. We want to keep that once. We want to store that once. So we create an item table. Every item, that's our inventory, right? And every item, we insert a row into the item table for every item in our inventory. And then when somebody does a rental, then we just take the ID, the item ID, and we insert the item ID into the rental item table, and that then links the item to that rental item, right, to that rental. Okay, so that's what we see by this relationship here. Okay, so the rental item table, the item ID, references the item table item ID. Okay, so that makes the item table a parent table to the rental item table. So the rental item table has two parent tables, item and rental. Okay, and you see how that relationship is depicted in the line. Each item, one item, can be rented many times, and so you see the one-to-many relationship on the right, the crow's foot. For each rental item references one and only one item. Okay, so each rental item, so when Sally comes in and rents Blu-ray Harry Potter 1, it's part of that one rental for Sally, and so that rental item gets inserted into the rental item table. The item ID gets inserted for the Blu-ray Harry Potter 1. Okay. Now I'm going to explain something here that is a limitation of this tool in MySQL Workbench. Okay, this shows a mandatory relationship here of item to rental item. This actually is not correct because there can be items sitting on the shelf that have not been rented, and if they have not been rented, they don't show up in the rental item table. So this really is an optional relationship, but in our reverse engineering, remember how we created this diagram, there's not enough information in the create table statements for the tool to know that that's an optional relationship. So by default, it makes it a mandatory relationship. And if we were a data modeler really working in here, we would go in and edit that relationship and make that an optional relationship, because in reality it's an optional relationship. It's just a limitation of the data that the tool had to work with in reverse engineering. It made it a mandatory relationship. Okay, now spend a lot of time on those three. I won't spend as much time on the others because now you understand how it works, right? But let's look at what these other tables are, what they represent. Okay, I'm going to scroll down so that I've got member and contact on here. Okay, member table, that represents a membership. Okay, so think of that as a membership. A membership can have multiple members, right? So a husband and wife and children within a family and whatever, they can share a membership. So a membership can have many contacts, and the contact is a person who participates, who comes in and does a rental. Okay, the contact is the person who does the rental. Okay, so a membership can have many contacts, and a contact can have only one membership. Okay, rule in our business. And then a contact does a rental. You see this line going through the address table. I'm going to move contact over here so that that line doesn't go through the table, but you see a contact can have can perform many rentals, right? So that's a one-to-many relationship, and every rental is rented only by one person. So so a one-to-many relationship of contact to rentals. All right, now address. A contact can have multiple addresses. We're allowing for that in our table, and you see that the address has city and state, but it doesn't have a street. It doesn't have street in it, because street address lines, a person could have multiple street address lines. You've seen that on occasion. Usually there's one, but we allow for them to have multiple lines in the street address. Okay, so to do that, again, we can't have a list. We could, do a set number of columns, but that would limit us to just those set number of columns and take up empty space when there is no when there are no additional lines in the street address. Anyway, in our model, we've got it in a separate table. Okay, street address. So one address can have multiple street address lines, and so we have one entry in the street address table for each line of that address. And so, and you see those are linked by the address ID of the address table. Okay. And one last table to talk about, the telephone table. So we see that a contact can have multiple telephones. They can have a landline, they can have a mobile phone, and so we allow them to have multiple telephones. That's a one-to-many relationship. And then you see that we have a relationship of telephone to address. Okay, and we have that an address can have multiple telephones associated with it, and a telephone, and you see that this is depicted as an optional relationship here. A telephone number may have an address or may not have an address associated with it. If it has an address, it's one address, okay? So if it's a landline, then the telephone will have an address associated with it. If it's a mobile phone, it won't have an address associated with it, okay? So, so we have established that one-to-many relationship, address to telephone, and then coming back the other way, telephone to address is 0 or 1. Okay, those are all of our tables. Now, what you should do, highly recommend, what I do, I have printed out this diagram. I put it by my computer here, and I refer to this diagram because when you get into constructing your SQL code, you will want to understand these relationships in detail, right? And that will help you by understanding the relationships between these tables. That will help you construct your SQL code, particularly in doing joins. Okay, and we'll get into joins in week 5. All right, so refer back to this table, this diagram. It shows you the table names, all of the columns, and the relationships, which are the foreign keys, which you will need in constructing your joins, writing your SQL code, and we'll be doing some very complex joins. Okay, equal file from the forward engineering, and that completes lab 3. All right.